So let us just do some assessment questions here. Okay, girls.
Didn't do page 340.
What?
Didn't do page 340.
Okay, I will check. Before that, I want you all to just do a few questions here. Maria records random speeds from 3 different internet providers in the table. Can you see in the question on the screen?
Yes.
Records random speeds from 3 different internet providers. Okay, these are the speed 3.6, 3.7, 3.6. And which companies you think offers the fastest mean downloading? This is the downloading speed per second. So what do you think? Which one gives the fastest speed? 3.67879, 3.9 to 4.1, and 3.9 to 4. So what do you think? Who gives the fastest one?
CityNet.
That is 3.6 to 3.9. Don't you think so? 4.1 is more faster. The highest number in all, where do you see? 3.9 to
4.1.
I feel that this is Able Cable. Able Cable gives you more. I think that. Let us check. The first one is CityNet. The second one is Able Cable. Let us check.
Impossible to determine from the.
Okay. Lucy collects data from a random sample of 7th graders. Out of 40 respondents, 7 attended after-school programs. Of the 207th graders, how many would be expected to attend after-school programs? Girls, try to do it. Again, I will say, Lucy collects data from 7th graders out of 40. This is that question, girls, we used to do. Out of 40, 7 out of 40 respondents. 7 attend the school out of 40. So out of 200, how many will attend? Multiply 40, divide 7 over 40, and then times 200. So it's 35. Did you understand how I did it? Again, out of 47 respondents attend after school program. So out of 200, how many? Out of 47, so out of 200, how many? What did I say? This will be division and this will be multiplication. This is, we have done in last term. Do you remember?
Yeah.
So this way, when I solve it, I get 35. So I'm going to put my answer as 35 and go to next question. Tricia surveys the student. Okay, she will read it. Just see that you can hear it or not. Wait a minute.
Tricia surveys students in her computer class about time spent on computers by students in her school. Is this a representative sample? Explain. This, a representative sample because students in computer class are to use computers than other students.
Okay, Tricia surveys student in a computer about the time spent on computers by student. Is this a representative sample? Girls, is this a representative sample? It is, and students in computer class are less likely to use computers or equally likely or more likely. Why somebody is checking that how many students are using computers? Maybe they're less likely to use computers than others. Let us see the review progress. Okay. Girls, let us submit these 3 questions and check, or let us go back. Wait a minute. No, it came out. Leave it anyways. This way I want to finish all of the questions at the end of the lesson, so that this lesson I'm not going to do quiz girls, because I told it's all about graph and everything. So I want better to solve it with you during the class. That's why I was solving with you. Anyways, here you mean we need to do this page? Which page you were talking about? Yes, Judy. I finished with question number 7, and you mean this page we did not do it? Read this question. Brianna asked 8 classmates. I cannot hear you.
Brianna asks 8 classmates how many pencils and erasers they carry in their bags. The main number of pencils is 11. The main number of erasers is 4.
Okay, 1 minute. The mean of erasers is 4 and the mean of pencil is?
11.
The friends could. Okay. Now she wants to make simple. By looking at the mean, I decide that the mean of the pencil is more. That means they carry more pencils than erasers. There's nothing else. Inference means by looking at this data, what do you take out your conclusion? I conclude by looking at the mean given here that Brianna's classmates, they carry more pencils when compared to erasers in their bag. Any question? Any question, girls?
No.
Question 10, I'm not going to do it. Question number 11. The dot plots show the weight of a random sample of fish from 2 lakes. Girls, this is called a Round Lake and this is called the South Lake. You see a sample here. Okay. See very carefully. This is the sample here from 15 to 21, and here the sample is from 11 to 21. This have a more range. Okay. And if you count, both have same number of fishes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Even this have 30, and even this have 31. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Both have equal number of fishes, but this is from the Round Lake and this is from the South Lake. Which comparative inferences about the fish in 2 lakes is most likely? There is less variation in weight between small and large fish in Round Lake than between small and large fish in South Lake. Less variation. Why less variation? Of course, the range is very less, girls, 15 to 21 only. Means mostly they are from the weight of 15 to 21, but here the weight is from 11 to 21. So they ask you which comparing, there is about the same variation. There is not same variation. Here they are 15 to 21, here they are 11 to, they cannot be same. They are saying South Lake, the variation is less. You have 11 kg, you have 12 kg, you have 13 kg, ounces. You have so many. So this is also wrong. There is not in the South Lake. Yes, it is less in the Round Lake when compared to the South Lake. Did you understand this? Variation. What is the meaning of variation? They ask you variation. What does this mean? Variation. That means vary. How they differ. Weight, differ. Again, the meaning of differ means, like example, there are two classes. In one class, the girls weigh from 35 to 60 kgs. The other class, they're almost all of them are 50 to 60 kgs. So of course, I will say the class which is 35 to 60 kgs, they differ, they vary. Did you understand this point, the word variation? Girls, did you understand this point?
Yeah.
Okay. I don't want to start with a new lesson probability. That's why I will get back to how many of you are here today? Except Majduleen here, right? No, Majduleen and yes, except Majduleen. I will start with a new lesson, that is chapter number 7. And later, if we are getting, now girls, this topic again, chapter 7, like it's not like 6, it's not that easy. It will take a lot of understanding, lots and lots of understanding. Please, please don't miss any of your classes. We have only 2 units left. With the 7th unit, we have how many topics? We have 7 lessons, girls. The first lesson, understand likelihood and probability. Girls, do you know the meaning of probability? Anyone? What is the meaning of probability? Did you ever hear this word in your life?
No.
Probability. Okay, do you know how to say it? Probability. Probability. Okay, probability. Now, if I ask you, did you ever hear this word? Ah, what's happening? Why I cannot make my edge? Did you ever hear this word in your life? What is this word? Girls, something I wrote on the screen. Please look onto it and say me. What did I write next to probability?
Chances.
Chances. Okay, what is the meaning of chances? Or chance?
A chance, like give a chance.
Give me some example. Like example, I have a coin. Okay, I have a coin of you know the meaning of head and tail? Do you know the meaning of head and tail in the coin?
Yeah.
We usually toss it, right? We try to toss it and we say that let's see. Like example, Zishan and Judy, you are not sure for some decision and you say, okay, let's decide whether we will go to the mall or not. Let's decide. If it is head, I'm gonna go. If it is tail, I'm not gonna go. So you are tossing it. So the chances of getting head, either you will see, maybe you have 2 coins, okay, or either you have head and tail, or tail and head, or both times tail. So you will not understand this until I start the lesson, but the word chance is like the chance of getting, the probability of getting something, the probability of getting a king while you're playing the cards. In this lesson, mostly what I studied in my school, in my college, was about cards, the cards we play, about king, queen, diamond. Did you ever play cards, girls? Did you ever play cards in your life?
Yeah.
Queen and what do you have? Diamond and heart. Those, I think we used to have that Uno cards, remember? No idea? Those who
Yeah, I remember it.
Yeah, usually we have 56 cards, girls. We have 52 or 56. Again, I'm not that sure because it's like ages that I have played any game such way. But let us again revise this. So we will have chances of getting head or chances of getting tail, or when you put a dice, you know the meaning of dice? Dice? Like when you are playing a Ludo, you know this game, Ludo? Do anyone have idea of the play of the word, the what do you call as game Ludo? Tell me, girls.
Jojo?
Ludo, Ludo.
Yes.
Dice and you get some number, and then you know the snake and ladder.
Yeah.
Girls, tell me, did you ever play this game, snake and ladder?
Yes.
Yeah.
How about others? Miran, Dana, did you play this game? From which number to which number do you have on the dice? The dice, what you throw. Girls, tell me, if you don't know, I'm going to show you on Google what is dice and what is everything. Girls, this is a dice. This is a dice. Do you know about this game?
Yeah.
Did you all play any time or no?
Yes.
Okay. Anyways, so we are going to, think that how many chances of we are getting 6 or we are getting 5 or we get probability is nothing but getting a chance. Okay, before it, let's see a video here, but I don't think so this video is usually effective to you. Okay. Let me just show you something, at least on probability. Come on, guys. Just see this video.
Good grammar and spelling are important, but if you want to write essays that inspire, messages that forge brighter connections,
because the video which is given in on our website, that is a little bit boring. He shows it very nicely, girls. Even sometimes if you don't understand some topic, even after you can watch his videos. They are really effective. I felt that he gave in a very good manner. Did you ever watch it before? His videos, Math Antic?
Yes.
Okay, so continue. It's like 11 minutes. I'm not going to show you the whole 11 minutes. I will quit and show you a few of them so that tomorrow we start this lesson with full enthusiasm. A very important lesson, girls. If you choose mathematics, or like if you want to become a pilot, or if your mathematics is a subject that you will always have to see, even if you choose commerce, even if you choose science, any subject you choose, you need to do mathematics. You know very well. So that's why this topic is very important in university, in grade 10, grade 11, probability will always be there. So please, if you know the basic well from now, grade 7, later it is easy for you. All right? So watch it.
Hi, I'm Rob. Welcome to Math Antics. In this video, we're going to learn about how to do math with things that only sometimes happen. They might be likely or unlikely. We're going to learn about probability. Usually in math, we deal with things that always happen the same way. They're completely certain. Like if you add 1 and 1, you're always going to get 2. If you multiply 2 and 3, you're always going to get 6. There's no uncertainty at all. But in the real world, things aren't always so predictable. Take a coin toss, for example. We can't predict whether it'll be heads or tails. It's unpredictable or random. And that's why some people will flip a coin to help decide which of two things to do. That's how I make every decision in life. Why am I not surprised? Oh no. Good luck. But even though we don't know what each coin flip is going to be, we do know a few things about it. We know that with a fair coin toss, that heads is just as likely to show up as tails. The probability of an event, like getting heads or getting tails, is a value that tells us how likely that event is.
See, here they are showing different coins, but you know our coins, Saudi Arabia coins. And we need to see the probability of getting a head or coin, and how are we going to say
this to happen. With our coin toss, since each side is just as likely, and there's only two sides to a coin, if we flipped a coin a lot of times, we should expect that about half the flips will be heads and about half the flips will be tails. That means that the probability of flipping heads is the fraction 1/2, and the probability of flipping tails is also 1/2. Let's look at this in a little more detail on something called a probability line. It's a number line that goes from 0 to 1. A probability is certain, common to write make a difference in its probability. Let's take a look at dice. A standard die has 6 sides numbered 1 through 6. When you roll it, any of those sides is just as likely to come up as the others. That sounds a lot like flipping a coin, doesn't it? Each side of a die is just as likely to come up as the others, and each side of a coin was just as likely to come up as the other. So you might expect that the probability of rolling a 3 is 50%. But remember, with a coin toss, there are only 2 possibilities, heads or tails. With dice, there are 6 possibilities, and that's going to make a difference in its probability. One way to think about it is that it's certain that one of those 6 sides will land facing upwards, which is a probability of 1 or 100%. But since only one side can face upwards for a given roll, we have to divide up that value among all the possibilities. In the case of a coin toss, since there were only 2 possibilities, we had to divide the probability by 2. 1 divided by 2 is 1/2, which is the decimal 0.5 or 50%. But with the die, we need to divide the probability up evenly between 6 possibilities. 1 divided by 6 is 1/6, which is equivalent to 0.167 or 16.7%. So that would be right here.
See, simple. Like if I ask that I am playing a dice, okay, and I got 2. So 2 you got, there's a chance of getting 2 one time out of 6. Why did I choose 6 in the denominator? Because I have to see how many total are there. Like example, if I say chances of getting heads. So you'll say 1/2 because I have chance 1 time. By their chances 2 times. If they told you in the question that you got 2 heads, 2 times you got heads. So you will say 2/2 that is. But in denominator, you have to have the, what you call as the final one. Now, we just have 4 minutes. Let us continue the video and then inshallah I'll finish up, and tomorrow inshallah I'll start.
Here on our probability line. That means it isn't likely that I would roll a 3, for instance, but it's just as likely as rolling any other number. And since all 6 numbers have the same probability, each number should come up about as often as the others. To see if they do, I'm going to conduct some trials. That's an excellent argument. Allow me to deliberate. Guilty. Actually, when dealing with probability, a trial, which can also be called an experiment, is a process that has a random outcome, like tossing a coin, or rolling dice, or spinning a spinner. And the outcome of a trial is what happens in that particular trial, like flipping heads or rolling a 3. So I'm going to conduct several trials by rolling a die multiple times and keeping track of how many times I roll each number. Aha! You said that each number was going to come up just as often as the other numbers. But look, there's more 2s than there are 5s. How do you explain that? Well, remember, we're dealing with things that are random. They're unpredictable. We can't know exactly what will happen, just what will happen on average. So now I have to calculate the average? Well, when we say on average, we mean that the more trials you do, the closer you get to the expected probabilities. Keep watching.
He's making you confused.
There. Now that we've done a lot of trials, you can see that our totals are much closer to what you'd expect them to be. I guess you're probably right. That's one of the really important things to keep in mind about probability. If you do just a few trials, the results might not end up very close to what you'd expect. In fact, they could be way off. But if you do more trials, you increase your chances of reaching the expected probabilities. There's another thing I should point out. Remember the probability of flipping heads is 1/2, and the probability of flipping tails is 1/2. The probability of rolling a 1 is 1/6, and the probability of rolling any other number on the die is 1/6. If you add up the probabilities for the coin flip, you get 2/2, or 1. And if you add up the probabilities for rolling a die, you get 6/6, which is also 1. And that's not just a coincidence. If you add up the probabilities of all possible outcomes of a trial, the total is going to be 1, or 100%. Because it is certain that at least one of those...
We'll continue tomorrow. Okay, take care and have a nice day. Not tomorrow. We'll continue probability tomorrow and see you in the science class after 5 minutes. Take care and have a nice day.
Bye.
Bye-bye.